Welcome, Casey, and welcome, André. Thank you very much for connecting as well. Today's presentation, it will be done by Casey mainly, and André will be on standby if there is a need for him to say something. André, you are also welcome to do so as a co-presenter. The topic is the importance of lighting, knowledge, testing, and design. So, the synopsis there says that lighting is an important factor that we take for granted in everyday life, which is very true. You know, the only time you will see the importance of lighting, it's when there's load shedding and you are sitting in the dark. So, yeah, we can all attest to that. And not only does it satisfy visual demands, but it also has an emotional, biological, and visual impact on humans. Human-centric lighting is a lighting concept that provides the required light appropriate to the user's living and working conditions at any time. This presentation will focus on the importance of lighting, the knowledge, testing, and design. So the presenter, Ms. Casey, holds a BA in Electrical and Electronic Engineering from the University of Johannesburg, and he started his career in Eskom in 2019. He's currently an engineer in training at the Demand Management Center of Excellence. And he's done a lot of work in these few years that has been part of the research team in e-mobility and also contributed to the publication of the latest intelligence brief on e-mobility. And he's also been part of the energy storage solutions team and the smart electricity platforms. This work primarily focuses on lighting and lighting design, where he has cemented his passion and expertise in this specialized field. He's registered with IESSA as a candidate engineer and has full membership in the Illumination Engineering Society of South Africa. André started working for Eskom way back, 1981, and mostly in generation, and has got the diploma in civil, including architecture, and also changed over to electrical engineering in 1986. So he's been part of the lighting design department. And also his big design project was on all the lighting of Majuba power station, and also done lighting consultation on Fossel and the Peaking power stations, representing Eskom, also at the SABS, NRCS, IEC, CIE, in technical committees. He's also a registered member of IESSA as an accredited lighting practitioner. And also André is also conducting some lectures in terms of lighting for basic to design stage for Eskom employees, but also for IESSA, and currently a senior advisor for demand management in Eskom. André and Casey are my colleagues. We are in the same department. I have visited the lab there, the lighting lab. I think in Africa, that's one of the biggest lab in Africa. It's state of the art. And hence, I was also attracted to the presentation that Casey did last week within the Eskom colleagues for various departments as part of the technical talks that we are also conducting at RTND. Hence, I invited Casey to do the presentation to the colleagues. Let me not take too much of your time. It's 3 o'clock now, exactly. Let me now hand over to Casey and André. Casey, welcome, and over to you. The floor is yours.
Hey, good afternoon, Lloyd, and good afternoon, fellow colleagues. Thanks for the opportunity to present lighting and lighting design. So once again, thank you for allowing me the opportunity and the platform to present the importance of lighting to the load research chapter. Once again, my name is Casey Fortuin, and I'm a young electrical engineer. Unlike André, that started way back in the 1980s. I started 3 years ago. I'm still fresh out of university. So the presentation on the importance of lighting is going to be based on my experience and what I've learned in Eskom RTND. So without wasting further time, let me get into the presentation today. The content that I will be covering is why lighting, the lighting parameters and characteristics, evolution of lighting technologies, services offered by Eskom research, testing and development, projects within Eskom, and the future work that the lighting lab will undertake. So the first thing that we ask ourselves is why lighting? And light is life, as it has a direct impact on our mind and body. Light is essential for people, animals, and plants. For a long period of time, before the existence of artificial light, natural daylight was the only light available. Artificial light refers to lamps and luminaires such as panels, floodlights, streetlights, downlights, bulkheads, etc. Modern lighting concepts combine both artificial and natural light for improved well-being and health. Humans have five senses. They are sight, smell, hear, taste, and touch. We receive over 80% of our information through our sense of sight, which indicates most of the information we receive about our environment is visual. Light is a key requirement for that. But light does far more for the human body than just permit vision. It controls many biological processes, and in the natural progression of daylight, also acts as a pacemaker for the human sleep-wake rhythm. Now, what is lighting design? Lighting design is specifically aimed at providing a visual environment for optimum performance of a visual task. These tasks can vary from desk work, theater rooms, assembly lines, just to name a few. Providing the correct amount of lighting for these working conditions requires a certain knowledge of the eye, its abilities, and limitations. Appropriate lighting without glare or harsh shadows can reduce eye fatigue and headaches. The pupil is the part of your eye that controls how much light enters. In the bright light, your pupils constrict, which limits the amount of light that enters, and in the dark, your pupils dilate. In other words, gets bigger, and that allows more light to enter. Now, the visible spectrum, the human eye only responds to a small portion of the electromagnetic spectrum. The range that is visible to us is between 380 nanometers and 780 nanometers. Beyond both ends of the visible portion are wavelengths we cannot see. Below 380 is UV, and above 780 nanometers is infrared. Now, when we speak about lighting, we have to take human-centric lighting into consideration. Now, human-centric lighting is a lighting concept that provides the required light appropriate to the user's living and working conditions at any time. Light is a natural phenomenon which is vital to our very existence, which we probably take for granted in everyday life. And in fact, we actually do take it for granted. As Lloyd mentioned, once it's load shedding, then you only realize how important it is because you'll be sitting in the dark. So not only does it satisfy our visual demands, but it also has an emotional, biological, and visual impact on human beings. And this can be broken down as follows. For visual aspect, good visual perception allows work to be done much easier. In order to achieve the required lighting, standards such as SANS 10114-1, which is artificial lighting of interiors, contain luminance values that lighting designers must adhere to. Now, luminance is the intensity of light emitted from a surface per unit area in a given direction. These luminance values ensures a safe working environment. The exterior lighting standard we follow is SANS 10389 here in South Africa. And if you didn't know, older people require higher levels of illumination to support their vision. For an emotional aspect, in hospitals, the emotional effect of lighting plays a big role in raising the spirits of patients. With hospital stays being generally unpleasant, a positive lighting atmosphere can raise the morale and makes the stay less intimidating and more comfortable. In the general unpleasant context of a stay in a hospital, a positive lighting atmosphere with a suitable balance of direct and indirect light can help raise the spirits of patients and make for a better orientation in the room. You can kind of picture it as those hospitals that you see in horror movies. They look so intimidating, and with all the dark rooms, it looks quite scary, and you wouldn't even survive in hospitals like it because of the lighting atmosphere. Now, with positive lighting, it will raise your spirits and you'll be more calm. Biologically, this must be considered and planned very carefully. The circadian rhythm can be affected. Now, the circadian rhythm refers to physical, mental, and behavioral changes that follow a 24-hour cycle. An example is the sleep-wake rhythm. It can support the demand for more productivity during the day or provide for a better sleep at night. Without daylight, the production of melatonin, which is the hormone that basically regulates our sleep-wake rhythm, is thrown out of the window. Now, that concludes human-centric lighting. And another aspect that we have to think about with human-centric lighting is also creating a safe environment. This is an example of a poor lighting design. As you can see, this is supposedly street lights, but all the lighting is centered on the island. This can create a harsh glare for motorists passing by. There's no uniformity. On a long stretch of road, if you're driving fast enough with a constant dark, bright areas that you enter, it can cause an epileptic fit as well. Pedestrians can't be seen on the other side of the road. So it's just a safety hazard for motorists and pedestrians and the general public. So these are things that has to be considered. So moving on to the color temperature. The natural light varies between 3000 Kelvin and 12,000 Kelvin throughout the day. Kelvin is the unit we use to measure temperature of light. It thus shapes the daily rhythm of human beings and influences our well-being, our ability to concentrate, and our sleep rhythms. To put it simply, the typical color at a particular time of the day either promotes or inhibits activity or relaxation. Circadian light can support the natural day-night rhythm of human beings. Lighting in offices and homes can affect our circadian rhythm. And how it can affect our circadian rhythm is with the exposure to blue light. Now, blue light is needed for good health. It boosts alertness, helps with memory and cognitive function, as well as elevates the mood. But blue light tricks the brain into thinking that it's daytime. When that happens, the body starts releasing a hormone called melatonin. And melatonin controls the body clock and is also nature's way of helping us wind down and prepare for bed. Light with low melanopic effect should be used at night, early morning, and in the evening. Blue light induces melatonin depression. If people are exposed to light with significant blue color proportion, this will disturb the circadian cycle and could result in sleeping disorders. Now, many people have these blue lights installed in their homes, like in their rooms, their garages, sometimes in the offices as well. And sometimes you think that, you know what, you have a good night's rest, but you wake up in the morning and you still have headaches or you're feeling tired. And that's just because of the exposure to the blue light. Warm light feels natural to us in the evenings and promotes relaxation. As part of our natural human circadian rhythm, warm light seems to relax us and help us wind down for the day and get ready for sleep. When dealing with dining rooms, ambience lighting and color rendering index are considered to show off the culinary delights and will add visual perception and appeal to the meal as well. It will also make you think that why in restaurants do they have a warmer temperature as compared to like pharmaceutical places which have these cooler temperatures. In a restaurant, when you're exposed to the warm light, you are more relaxed. But as soon as you walk into stores with this harsh blue light, you are suddenly awake and you just want to get out of there as soon as possible. And that's basically, in a nutshell, what how color can affect us. There are three different scenarios that you can see. Each is using a different color temperature. Warm white is classified between 2700 Kelvin and 3300 Kelvin. Natural white is between 3300 Kelvin and 5300 Kelvin. And cool white is above 5300 Kelvin. Another concept we speak about is color rendering index. Now, color rendering index is a measurement of how how natural light renders under an artificial light source when compared to the sun. The index is measured from 0 to 100, with a perfect 100 indicating that colors of objects under the light source appear the same as they would under natural sunlight. High CRI lighting renders beautiful, vibrant tones across the full color spectrum. Here's an example of the same apple under four different lighting conditions. They are all under the same 2700 Kelvin temperature, but at different CRI values. Now, a CRI value between 95 and 100, colors appear as they should, and they are primarily used in movie production, retail stores, and art galleries. And also it makes the apple look nice and juicy. But as you lower the CRI value, like at 90, almost all colors are distinguishable. But if you look at it at the color rendering index of 70, the colors look desaturated and mostly unidentifiable. The apple looks rotten and you wouldn't want to eat that. And speaking, and as I mentioned just now, that it's used in retail stores. Have you ever noticed that as soon as you purchase clothing items in retail stores, they look so nice and vibrant in the displays. But as soon as you go home and actually wear them, they look much different. And that's because of the lighting that is used in retail stores. Here's a different comparison that we've done in our laboratory at Eskom. There are three examples. The one on the left is under a cool white light source, and you can see the blue spike on the wave spectrum curve. And in the picture represented there under, you can see the blues are more dominant, and it has a CRI of 77. The second image, the reds are more dominant compared to the blue, and it is clearly visible. But in the final one, you can see there's a nice even tone to all the colors. That is an example of a perfect light source with a CRI of 99.5. And that's just how the lighting effects can bring out the colors. And this is the same cloth, but just using three different light sources. Now, moving on to the evolution of lighting technologies. Lighting technologies have evolved for decades and decades, and they are continuing to evolve. From the oil lamp to gas lamps to fluorescent lamps, and now to modern day LED lighting, which we all are still getting used to. Now, LED lighting are the light sources of the 21st century. The advances in LED lighting have opened up many new possibilities in lighting design, but at the same time have also changed the general requirements of the lighting environment. They are now even exceeding the output capacities of previous light sources, from torches through to general room lighting and high-powered floodlights, with significantly better power consumption values and much greater flexibility. Today's LED light sources claim to be suitable replacements for all previous available lamp technologies. Now, some advantages of LED lighting includes higher efficacies. The efficacy is a measurement of how much light a source produces for the energy put into it, and this is measured in lumens per watt. Lumen is a measurement of light from a source, and watt is just a unit of power. LEDs also have a lower line current, lower power consumption, a higher power factor, and there's also less maintenance required. If we compare lighting technologies, here's an example that we've done in our laboratory with a 60-watt incandescent lamp, a 15-watt complex fluorescent, and an 8.5-watt LED. The 60-watt incandescent we have in the lab produces 660 lumens. And lumens, as I mentioned, is a measurement of light from a source. It consumes 61.7 watts of power. It only has an efficacy of 10.7 lumens per watt and a line current of 0.268 amps. Comparing the 15-watt CFL to the 60-watt incandescent lamp, you can see that the CFL uses nearly 4 times less power. It has 4 times higher efficacy and nearly half the line current. Thus, it produces as well about just over 100 lumens more. Comparing the 60-watt incandescent to the LED, you can see that the LED uses nearly 7 times less power. It has 9 times higher the efficacy, and it uses 3.5 times less of a line current. Now, this might not seem a lot, but in a large installation, it will make a huge difference to electricity bill at the end of the month. Now, if you compare the CFL, the 15-watt CFL we have to the LED has 56 more lumens produced. It uses nearly twice less power. It's nearly twice the efficacy, and it also nearly just over 1.5 times less of the line current. That's just the evolution of where we're heading to. Moving on to bigger lighting technologies for bulkheads. If you compare the 70-watt high-pressure sodium to a 50-watt replacement bulkhead, you can see the 70-watt, according to the table, these are results we obtained from our laboratory. The lamp flux of a 70-watt gives you 5,600 lumens, but once placed inside the luminaire, which is also known as the entire electrical unit, it only gives you 3,212.9 lumens with a light output ratio of 57.4%, meaning majority of that light, like 42% of the light, is lost inside the fitting. The efficacy is 39.36 lumens per watt. The power factor is 0.83 with a line current of 0.42 amps. Comparing the 70-watt HPS to the 50-watt bulkhead LED retrofit, the total output for the the 50-watt LED is 5,883 with a light output ratio of 100% compared to 57.4. The lumens per watt is 119, which is nearly 3 times the high efficacy, and it uses also half of the line current. Comparing a 100-watt HPS bulkhead to a 67-watt, for example, you're looking at the 100-watt lamp producing 9,500 lumens, but put inside a bulkhead fitting, you're only getting 6,098 lumens out of that fitting, meaning only 64.2% of the light output there. Comparing it to the 67-watt LED, the LED has twice the efficacy at 123.19 lumens per watt, and also it uses nearly half the line current as well. Plus, the LED gives you 100% light output ratio and nearly 2,000 more lumens as well at 7,902. So these are the services offered by Eskom Research, Testing and Development. We do offer specialized luminaire performance testing, lighting designs for interior and exterior applications, consulting services, and of course, lighting courses that Lloyd has mentioned. Now, these lighting courses are available for Eskom employees, but for external courses, you can do it through IESSA, which is the Illumination Engineering Society of South Africa. And speaking of IESSA, the laboratory staff have full membership in IESSA. Now, the lighting industry of South Africa is represented by the Illumination Engineering Society of South Africa. IESSA represents South Africa internationally and thereby acts as the national committee of the CIE. Experts in the various fields of lighting serve in the CIE committees responsible for the development of standards for different aspects of illumination. The laboratory is also involved with subcommittees and working groups in the SABS for lights, lamp sources, luminaires, LEDs, interior lighting, emergency lighting, sports lighting, and public lighting. The standards that we do test against in the laboratory is SAN 17025, which is the general requirements for the competence of testing and calibration laboratories. CIE 025, which is test methods for LED lamps, LED luminaires, and LED modules. SANS 475, which is the performance requirements for luminaires, for interior lighting, street lighting, and flood lighting. And last but not least, SATS 17576, which is the performance requirements for LED lighting, LED products for interior lighting, street lighting, and flood lighting. This is an example of one of the instruments that we do use, which is also known as an integrating sphere. Now, the integrating sphere is primarily used to test lamps and linear luminaires. It's also used for flux measurements and optical attenuation. Now, for more detailed tests, we go to our bigger machine, which is known as a goniophotometer. Now, this machine stands at just over 4 meters tall, and it weighs a couple of tons as well. This measures the intensity distribution on the C planes. It can also measure the CIE, alpha, beta, and gamma solutions with our software that we use, and is also highly accurate and can accommodate all light sources. Now, in this room, we set it's as per standard. The temperature is 25 degrees plus minus 1, and also this room is quite dark. When I say it's dark, I mean it's actually darker than dark. On a full moonlight, the amount of light that you get, that you can see on a full moonlight is 0.1 lux. Now, lux refers to is a standardized unit of measurement of light level intensity. As I mentioned, on a full moonlight night, it's 0.1 lux, but in this room, it's 0.01 lux. It's very, very dark. If you put your hand in front of your face, once the lights go off there, you would not be able to see the outline of your fingers. The reason why it's so dark is so that there's no other light that interferes with the test results that we do obtain for the photometry. Now, I'll get into the photometry in just a few. The operation of the goniophotometer is as follows. The light source is mounted onto a bracket and is shining downwards towards the floor with the big mirror rotating at full 360 degrees around it. As it is in rotation, the light is bounced from our big mirror to a mirror that's 10 meters away and thus moves back into, reflected further into our long distance sensor or our far field detector. After each revolution, the luminaire is rotated like by 1 degrees, 2 degrees, 5 degrees, and so forth, depending on how you set it on the horizontal axis. So for each revolution of the mirror, the lamp rotates, and thus it gets what's known as your photometry. Now, your photometry can be seen as follows, and this is a perfect example that I'm showing as to why you can't just replace a light fitting with anything else. Each light fitting is different, and this is an example of that. Between luminaire 1 and luminaire 2, they are the exact same light fitting, but they have different photometry. Comparing luminaire 1 and luminaire 2, you can see that luminaire 2 has a wider distribution compared to luminaire 1. It also has a more forward distribution, and it also throws more light to the back. Looking at a 3D representation of that, you can see luminaire 1 does not throw or protrude light as forward as compared to luminaire 2. It also doesn't have a much wider uniform distribution compared to that, and also it has less light shining backwards. Now, if I may, I'm just going to show you what we do with this the photometric files we do get. I just want to show you a design that we've done. So in our software, we bring the photometry in, and we do require drawings, and we give you an actual model of what the scenario is. This is an example of the Eskom Corona cage facility just behind Megawatt Park. So we give you an exact representation of what it is to scale. We also require dimensions on the drawings as well. And where the photometry comes in, you can see how the place is lit up. Let me just get one floodlight and show you how it looks. For example, this is where the photometric data comes in. Strategically positioning the light fitting. And each photometric distribution of the light fittings used here is much different. And in the end, we give you a result that will give you close to real life of how your exterior or internal application will look once fully lit up. With this application, we can also give you the Poseidon colors. Just waiting for it to change. Okay. This is your Poseidon colors. It gives you a scale to see how much lux you're getting at each specific spot. And this is to ensure a safe working environment for operators at any given time. It also adheres to the SAN standards, and we also do ensure that needs to happen. Coming back to my presentation. So now, part of the projects that we do have in Eskom is the Corona Cage Test Facility, which I've just spoken about. This was a recent design of mine that we done about 2 months ago. For general lighting levels, for example, for an area like this, for accurate work such as general servicing of work and reading of instruments, you require 100 lux. Overall inspecting, you need 50 lux. In traffic areas where there's pedestrian movements within electrical safe areas, you require 5 lux. And then we also, like in substations, this is how far our designs can go. We can give you an accurate representation of that. For security purposes in substations in low risk areas, or it's 5 lux. High risk areas in switch yards such as this, you require 50 lux. For example, as well, there's an overview of power station. This is just also how far we can go with our software. For like turbine halls, you need 300 lux, boiler rooms, 150 lux, switch houses, 200 lux, etc., etc. These values are stipulated in the standards, and they are not for personal preference, but they are there. They are standardized values to ensure a safe working environment. Coming to interior lighting design as well, this is another one of my designs that I've submitted. And for office workstations, you require a average luminance value of 500 lux, restrooms 100 lux, canteens 200 lux, stairs and escalators 200 lux as well. The standards that we do use before I continue now, for another thing about interior lighting that I forgot to mention, for interior design applications, specific design criteria and luminaires are required to meet the stringent demands for good visual conditions to allow the operators to function without excessive strain and fatigue. Ergonomic considerations need to be taken into account, and it will be important with regards to the seating posture, desk, and monitor height for a good head and line of sight position. This is to reduce glare while the operator is conducting work. Now, in order for us to conduct an interior design, we will need like a final layout of the office area or anything. because that will influence the strategic placement of the luminaires, as well as using specific luminaires with different distributions to limit the glare. Coming back to the standards that we use for lighting designs is like SANS 10114 for artificial lighting of interiors that I've spoken about. 10114-2 is for emergency lighting. Then our exterior standards we use is SANS 10389-1, 2, and 3. That's for artificial lighting of exterior areas for work and safety. Exterior security lighting, the guide and limitation of effects of obtrusive lighting from outdoor installations. Basically, that gives you the limits of the relevant lighting parameters to contain the obtrusive effects of outdoor lighting, and also why you should adhere to that is if you're driving past a building, for example, the lighting from factory or warehouse on the outside shouldn't interfere with your driving, or it shouldn't shine into your yard. It's just to prevent that. Other standards we do follow as well is SANS 10098-1 and 2. That is the lighting of public thoroughfares and the lighting of certain specific areas of streets and highways. And last but not least, SANS 204, which is energy efficiency in buildings. There are some Eskom standards that we do have in place though, and there is a generation power station lighting and small power installation standards, LED lighting for Eskom properties, security lighting for Eskom applications. Now, these have been published in Eskom, and you might ask, like, what do we consider a good light? Well, in these standards, there are some requirements that we must adhere to before installation. For example, one of the requirements is your photometric requirements, where the CRI value must be greater or equal to 85. The efficacy should be greater than or equal to 110 lumens per watt. You must also provide photometric test reports from accredited laboratories. Electrical requirements refers to power factors, operating frequency, and voltage. Electromagnetic requirements is compliance with EN 55015. Mechanical requirements is the comprehensive test reports indicating that the luminaire successfully passed SANS 475. Guarantees luminaire housing with a minimum period of 10 years, as well as electrical components and LED modules must last at least 30,000 operating hours or 5 years. We also require a maintenance strategy, which involves the cleaning and general bulk maintenance and bulk replacement of luminaires. We also want a proposed Relux design. We also require your IES files, which contain your photometrics, and we also want the actual luminaire sample so we can verify your results that you brought from the accredited laboratories with our results. And that way it minimizes people from forging or faking the result output. The future work that the Eskom RT&D Swan Edison Lighting Laboratory will conduct is pre-compliance EMI and EMC testing, which is your electromagnetic interference and compatibility, as well as investigating the effects of harmonics emitted by LED luminaires. And yep, that is it for my presentation. Thank you so much once again for the opportunity to present. I hope that you have found this information useful and that you've learned more about lighting and lighting design. Thank you.
Thank you very much, Casey, for the very informative presentation. Before I open the floor to the members for questions or comments, Andre, is there anything maybe that you just want to say?
I think Casey had covered everything. He did mention that we're asking for an Eskom installation, that we're looking at EMC testing. We've actually purchased instruments now, and in the near future, I would talk, I'm saying at about next month or so, we have been trained, so we're going to try and play with the instruments and get that testing done as well for illumination in our stations, because we picked up that with the LED products that's on the market, some of them do have a lot of noise, and it's going to start interfering with radio signals, and it might be able to interfere with CNI signals and controls as well. So that's why we're going that direction, to make sure that anything that is installed on our premises and our power stations, that they are a good product, that not everybody, because you get contractors that going around to Solly shop, go and buy any anything that you would get, put it in, and would expect the client that they would need to be happy. So we make sure that there's good products installed so that we don't have any of the problems in the near future as what you can expect from cheap products. So yeah, that's basically covered very well by Casey, everything. And any questions?
Thank you, Andre. Looking forward to some of the future work that you are going to embark upon. Colleagues, questions, comments? I see Esrom, your hand is up. You are the first one, Esrom. The floor is open. Over to you.
Okay, thanks, Chair. Thanks, Andre and Casey, for the presentation. I think it's very necessary. I'm currently working with the municipalities. Majority of their project, 80% of their project, is actually retrofitting street lights. And we've actually picked up this issue where people just bring some luminaires from, I don't know, and you can see that something is not really right here. But we don't have that facilities where we can actually test this luminaires. I think it's something that maybe we can take it offline. Us and Andre maybe can also maybe we can see how we can work together on that. But my question would be, since I know that I think they are in a process of getting that lab to be SANAS accredited. So if somebody brings a luminaire to Eskom, let's say Eskom wants to procure some luminaires, and then they take the luminaires to their laboratory and they test it there, and then they disqualify that lamp. Won't there be any legal implications? Because maybe the person can say, no, but your lab is not SANAS accredited. Even though I know that most of my colleagues and other people, they told me that probably your lab has got some of the finance testing equipment. But the mere fact that it is not yet SANAS accredited, are there any legal implications? I think let me stop there. Maybe I can ask other questions later if they still time. Thank you, Chair.
All right, thank you, Esrom. Andre, would you like to respond to that?
Yeah, Esrom, I can actually answer that question. We are currently testing light fittings for City Power. A lot of the light fittings that they did brought it to us. We tested it for them. So we're working very close to City Power on their street lighting, where they're replacing the HID with LED lighting. So it's not a problem. We were asked the other day by the only accredited laboratory that we've got in Gauteng to do their to be contracted out to us. So we are comparing, and we are the only lab in South Africa that actually did international comparisons. We did it in 2017, comparing to the world. It was including Europe, Asia, Australia, and the Americas, that we were the only lab in Africa that actually compared in that international benchmarking and interlab comparisons. Now, beginning of the year, we did some testing for NRCS, and it is a European country that run it, CLASP, where they've done sub-Saharan lab comparisons. We were also the only one in South Africa that took part, where Ghana, Kenya, Zambia, Burkina Faso, and all those countries was involved as well. So we are already at that level where we compare nationally. It's just a few semantics and technical things that's actually holding us back to be accredited. Like I said, we are there's only one that's still accredited in South Africa, and that is a lab in Joburg, north of Joburg in Wynberg. SABS is still working on their new lab to implement and to put new instruments in there as well. So yeah, we are comparing to the best out in the world, and our reports that came back as the comparisons and the feedback was very positive from our side as well. Ezra, one thing that I want to mention is I'm staying in the West Rand area where Roodepoort municipality is replacing a lot of the street lights with LEDs. Anything that gets replaced from one type of fitting to another one, I doubt nobody had made any design. So the lighting that they replace it with is of poor quality. When it fails, they put the old HIDs back. I don't think there was any designs done to do a replacement of light fittings. So we would like for the Munichs to have a look at how they do the replacements of the light fittings in the streets, because street lighting is there for safety reasons, to make sure that people traveling safely around from point 1 to point 2, and that pedestrians and that is visible so that people don't get run over or things like that. So I think there's a big lack of knowledge of how to install light fittings. They don't use the standards 10098-1 and 2. They don't even look at those standards. So I'm actually putting out a word out there. Anybody from the Munichs, please make sure that the installations that you do it correctly and do it with a good product. I know some of the products that I did test for City Power, it wasn't passed. It was bad quality light fittings. There wasn't even a label on where it came from or anything. So I think it's the substandard products that's out there. I think we need to eliminate that, because it's making the world around us not a safe place to work with and to go out there and move around. So that is just some of the ideas that I want to throw out there. Please make sure that the redesigns are done and things like that, and make sure, get the better product. We buy pay a little bit more extra for it. You make sure the photometry is right, your light outputs is right, and the installation is a critical part that needs to be installed correctly, or else you jeopardize safety all over. Thanks a lot.
Thank you, André. Marcus, you are next. Your hand is up.
Thank you.
Then after that, it will be Vasu.
Thank you, Lloyd. It's interesting you're talking about light and perception. There is this thing where perception changes over time at different light levels. So there's some sort of form of accommodation that happens. We all know that we walk into the dark, and over a number of minutes we can start to see and operate. That's very interesting. The first question, just park it there, is what's going on there, and has that been mapped in some way? Then the next thing is, with a lot of these light designs, there's two things that affect them. The one is the spill lighting or light pollution from adjacent areas that probably affect your design, and then the other one is the absorptivity of surfaces. So you can do a lighting design for, say, an office area, and as soon as the workers start to bring themselves and their computers and their jackets and papers and books in, suddenly things become a bit darker than they originally were. How do you compensate for that? It looks like, a third point, looks like at the moment we getting into a place where, a light used to be a combination of a light source and a light fitting. And with the LED devices that we're seeing coming in, that light source and fitting are actually integrated. So it looks like there's space here where standards must sort of catch up. If you could comment on that, please. Thanks.
Okay, thanks, Marcus. André, Casey. André, over to you. Are you going to, I see your hand is up.
I can answer on the standard and the light levels to test. I just want to share a document that I've got here to show you how far we've gone and what the people were doing wrong to do the correct designs and stuff. Now, as you know, SAIEE 10114 is the one that we use for interior lighting, for instance. Now, this is a working document that we had with a work group and working for, doing for this. Now, Table 1 is the one where we see the light levels and that. Now, the recently 2020 version that was published don't have a column 6 here, for instance, because when everybody started looking at energy efficiency and all those figures to save energy and to do the lighting designs and that, then they were starting to look at column 6, and that's your SA legislation column where your OSH Act comes in. Now, on the new standard, this column is not even in there. We didn't even mention the OSH Act in this paragraph that explaining what we're looking at, because energy efficiency made a lot of wrong things. People go out, they design on the light levels of the OSH Act, and then just a little bit of dust. It's under this light level, and then your light levels weren't right. That's why we took it out. The standard that needs to be used, or the level that needs to be used for that type of installation, and as you can see, your offices and that type of thing, it's all higher levels than what we see on that side. I think if I go down to offices, it will be a more clearer figure. Now, all these levels, as you look at it, it's from 500 down to 300, for instance. That gives you a depreciation level in there. So any light fitting, any light source can depreciate up to that level. When it comes to that level, you need to either replace, clean, or do something about the lights to get it up to the better light level that is stated. And that is average illuminance that we're looking at. So that's why if you do the design, and as you see, we do interior lighting, we try to place furniture and things like that. If you've got dry walling screens and that type of thing, try to put that in, because that also absorbs a lot of light. It reflects, or sometimes reflect the light that gives you more on the one side than the other side of a dry walling, for instance, or just cutting off light levels. So you need to make sure that your designs, and because of the electronic simulation programs that we've got nowadays, you can simulate it so close to what the real incident is, and it makes it so much easier to see what your end product on the design will be. So it makes it easier, yes. I didn't get the first question that you've asked actually clearly. So yeah, this is part of it that we're looking at. From the lighting fraternity, the specialists out there, we did take out those levels to stop people do the wrong designs. The other questions that was there, Lloyd, I didn't get them clearly.
No, that's fine. That's fine, Andre. I'm just mindful of time as well. Casey, you wanted to comment also before I go to Vasu?
Yeah, I just wanted to show Marcus, like he spoke about the obtrusive lighting. So I just want to show him in this corona cage design. So you have to be very considerate as to when you're choosing your luminaires. The one challenge that we did face with doing a design for the corona cage facility is like right here behind it, like along this wall here. Well, I didn't include the wall in the design, but there's an old age home, and they've been complaining about light that is being shining into their premises and so forth. And depending on the distribution that you do get from some light fittings, some of them have a round ball where it throws a lot of light backwards and so forth. This one is quite controlled, and it only allows a fine amount of light there. If you look at the table, the analysis, you can see along the wall, you only get 2 lux, 1 lux, a maximum of 25, and it's basically like nothing as well. So those are taken into consideration before we give a final design for installation. I hope that answers that question.
Yeah, just a point. It's interesting. A lot of what happens to an installation happens after the designers have left. And then you get all manner of operating stuff that happens. And guys tend to repaint surfaces and so on. And I guess that must be quite frustrating for lighting designers. Thanks.
Yeah, and also like coming to the offices, when I mentioned like in the presentation, we need like the full layout, meaning your desk layout where your laptops are going to be possibly be sitting, your chair positioning, the colors of the walls, as that also impacts on how light is reflected and how light is absorbed. So we do take that into consideration.
Yeah, but it's what happens once it leaves your hands, which is is part of your challenge.
Yeah.
Anyway, I see Vasu's got a question. Let me step out.
Yeah, because Marcus, that's very true. Because what happens operationally during maintenance, what people do afterwards, sometimes they mess up what has been initially designed, which is very true. So dealing with that, maybe let's hear from Vasu's side how do they handle things like this, because he's also from eThekwini. Vasu, you had your hand up.
Hi, Lloyd. Yeah, thanks for the opportunity. Thanks, Casey and Andre, for your presentation. Yeah, so basically we've rolled out quite a bit of LEDs in eThekwini, and what we've noticed is that initially we were having a lot of failures with them, and thereafter I think the supplier managed to get that right. But my question is more along the lines of how do you ensure that your LEDs are performing as well, let's say 3 or 4 years down the line, in terms of I think Andre did mention about depreciation. Are you able to test for this, or do you just expect the depreciation to happen over time? That's the first one, and the next one is more about DC LEDs. Is this something that's coming into the market? Are you all seeing it for like commercial and industrial, even domestic purposes or uses?
Yeah, there's a lot of DC lighting coming in, specifically when you start looking at PV powered DC LEDs and that. As soon as you swap over from alternating current to DC, people need to remember that the control gear needs to be changed, because it's not that conversion that you're actually working with. It's maybe lower voltages. So yeah, the control gear needs to be changed first before you can go in there. Different installations, different type of control gear. Yeah. So yeah, you would see things like that, but we need to make sure that the installation and it's technically people that technically know what they're talking about by selling your light fittings, because you need to make sure that the light fittings that you use is fit for your installation and that it will be good for the long term as well. It's not. That's why we're trying to stop people buying somewhere from any installation lighting supplier and that, because over the last year since LED lighting came in, it actually, the lighting suppliers increased by more than 200% over the last few years, and that we need to make sure that it's not just everything and anything that you install. At the Durban area, we did some tests before as well, and I can actually show you. These are things that you need to look at when you're in your coastal areas. We had a lot of, this is between King Shaka Airport and Umdloti, where this was installed on the highway. Not one of these light fittings are actually operating anymore. I think you guys are thinking of replacing this now. So yes, you need to make sure that the fittings that you install, it looks good when it's in the shop. The salesman will sell you whatever you want to buy, but then it starts to deteriorating. As you can see, the quality, there's only 2 strips of the LED working and things like that. It's busy rusting into pieces. So yeah, you must make sure that these things are good qualities and that you make sure that you buy it from a reputable company where you can always go back to get after-sales services, because not all the shops are doing that. So make sure what you put in and how you put it in. Thanks.
Okay. Thanks, Andre. Yeah, that's always an issue between the architects and the engineers, the type of design, and each one's got his own way of looking at things.
I see, Esrom, your hand is up.
Oh yes, Andre. I think maybe thanks. I might have missed it in the presentation. My understanding is you guys do mostly the optic tests, and then I heard you saying you're gonna do the EMCs now. What about the thermal testing? Because what I've seen as well is that I've seen a situation where I see a luminaire, but I start doubting the heat sink that they have the. I'm thinking that maybe this heat sinks might not be good enough, because my understanding is that if that heat sink is not good enough, that luminaire will actually die very quickly.
Yeah, we've done some. Yeah, I've done some because we've got environmental chambers available to us as well. I've done some testing previously for a lighting company that had an order for the Arab countries where they wanted to install their light fittings. We've put it in the environmental chamber and we pushed it up, because it's your ambient temperature plus the heat that's created inside the light fitting. And if those two increase so much that you're gonna get failures in your luminaires, then you must make sure about that. So yes, we have done testing like this before to make sure that your gear tray where the driver and all that is in, that the temperature in there doesn't increase too much, so that it influences the performance and the lifespan of the light fitting.
If I hear you correctly, are you guys still doing these tests, or it's something that you've done before, or are you still doing them? Some people can come to you for it.
Yeah, but we haven't done it now for a while, but we still can do it because our environmental chamber can work from -25 up to 80 degrees, I think. Lloyd, just correct me if I'm wrong. We've done things like that before, so it is we can do it, and we are looking at expanding to that type of services as well. We've got about 46 or 48 external clients, lighting manufacturers and suppliers, that we do testing on a weekly basis. So yeah, we don't only work for Eskom, we work for the outer market as well. Marcus, you've got a question?
Yeah, thanks. It strikes me that with the light being made up of the light source and the fitting, and it's integrated now, the engineering challenges that you face are very similar to that, the introduction of prepaid meters with the sort of holistic engineering testing that's required and the standardization and so on. And that goes to the accelerated aging and so on as well. But it still seems to me that we are kind of behind on the standard side in South Africa, in that products that are not suited to this environment surely should not be imported into South Africa. Or am I being too prescriptive there? Thanks.
Yeah, you see the lamp life or the LED lamp life, and that is worldwide now is actually a projected figure that we're working at. In the old days, when you had an incandescent lamp, the lamp life was 1,000 hours, so you could put it in and switch it on and off in a controlled environment, and you could project that 4 times of the lamp life of after you got the 50% failure on the group of lamps that you tested. And that was projected 4 times to get the actual lamp life of a incandescent lamp. But now with LEDs, people coming in and they say it's a 50,000 hours, or some people came in 100,000 hours, but it's not tested. Those are all figures projected. Now, they are working on it worldwide now from CIE and IEC side, so we can have figures and calculations to actually start working on that. But it depends on the environment. If you install it in South Africa or in the South Pole, there's 2 different conditions. So that light fitting will have a different performance levels and lamp lives and things like that. So yeah, it makes it very difficult with the LED environment that we've got currently, and we're all working towards it to get our standards up to standard into this for the South African environment. But it's a difficult issue that we cover, or that we're trying to bridge at the moment.
Yeah, with the SABS mark, and so on. They've kind of standardized the battery of tests and for a device or an installation, and you won't, if you don't pass those tests, you won't get the mark, and therefore you shouldn't be allowed to vend those products in South Africa. So it sounds like we're not quite there yet. Thanks.
Yeah, we're still not there. We are working on it. We've actually got a SABS meeting coming up now, in 2 weeks' time, that we're going to try and work through all these things. It's a time-consuming thing to get all the documentation up and running, to get the specialists together to work and get these things out into the public so that we can use it when we do designs or manufacturing of LEDs or light fittings. The manufacturers that we've got in the country, they are working very hard to get the correct light fittings out there. Mainly when you get imported from Europe on your colder areas, you bring in light fittings, and that's where we're starting picking up problems as well. And then the control gear, for instance, it creates flickering and disturbances and things like that, because the environment where we install it in Africa is totally different to what the European environment is. And that is where we're picking up problems. We need to get all our things up in line and published out there so that we can have something to work against here.
Yeah, it sounds like a typical sort of leading edge problem. And until it becomes, what do they call it, bed and breakfast or something, commonplace, and everybody knows how to handle it, and that's what we're busy doing right now. Thanks.
It's sort of, yeah, I think you spell it out correctly there. Lloyd, any more questions from the floor?
Marcus, I see your hand is up.
My question, you don't have to answer it, but do the gents around the table have any idea of what portion our evening peak that we're having at the moment is of lighting load? Thanks.
Unfortunately not. We had figures many years ago, but it increased so much over the last couple of years with where our grids expanded so much. So yeah, it's going to be difficult to actually get that type of peak on the lighting, because we know there's a lot of installations and connections that you can't calculate those ones that's been done. It's going to be very difficult at this stage.
Yeah, it sounds like your target is potentially to, with this type of lighting, to reduce that lighting load by a factor of 3 potentially, that which hasn't been addressed. That's quite significant, eh?
Yeah, luckily the LED, or if we talk about the GLS lamp, your general services lamp, the prices came down tremendously. The CFL compact fluorescent prices actually went up a bit, and then incandescent lamps that's still available out in the country, their prices are so that people now thinking twice before they buy an incandescent lamp to put it in. So yeah, hopefully we can shift the mind to go more to the LED side, but people need to be educated in LEDs, because you want to replace an incandescent lamp. A 5-watt lamp, a 6-watt lamp won't do that. Not even some of the 8-watt lamps that's on the market won't replace a 720 lumens lamp with a 400 lumen lamp. That is impossible. People need to be educated how to read the box and make sure that they get the correct equivalent. Only then people will see that LEDs are actually a good light source that we can walk forward with. That makes it difficult.
Yeah,
All
André,
right, thanks.
Thanks very much. Eskom, this sounds like a very worthy thing to go out and market aggressively. The national benefit is great. Thank you.
Yeah, in actual fact, Marcus, lighting and LEDs, it's one of the products that have been identified for the purpose of energy efficiency drive currently in the country. So, yeah. Colleagues, unfortunately, we are way out of time. It's now 4 minutes. And let me thank Casey and André to come and present to us about lighting, the importance of lighting. We really appreciate that. So I was actually just saying that when there is a need for us to be able to see some of the labs, we should be able to arrange that in time, in due course. So we will see how that one goes. So there are many things at RTND that we can arrange for a tour. So that kind of an industry tour, I think we need to arrange very soon. Andre?
Lloyd, thanks. It was a pleasure to join you guys in the meeting. And yes, Lloyd, I think we can set the invitation out to come and visit us. Yeah.
Yeah. Thank you very much, Andre. Colleagues, if there is no other thing, thank you very much for joining. With the power vested in me through the South African Institute of Electrical Engineers and the Load Research Chapter Executive Committee, I now declare this meeting over. Now the time is 5 minutes past 4. This meeting is adjourned. Thank you.
Thanks, Lloyd. Thanks, Eskom, for attending. Much appreciated.